In this lesson, we're going to be covering the slope of a line as well as linear equations and y-intercepts. In 5.2, we'll talk about the unit rate, and we'll determine how to find the unit rate of a graph as well as an equation. So looking at this first example, we have a graph here and it's asking what is the constant speed of the car. Well, I know that speed is the same thing as unit rate, and we represent unit rate as the equation of y over x. And so if I look at my y-axis on this graph, it's distance, and my x-axis is time. To set this up in equation, it would be distance over time, which our distance we traveled at 30 is our time at 1 hour. So we traveled 30 miles in 1 hour. So when I put that in my equation, it's just 30 over 1. This is simple, and it simplifies as in speed is 30 miles per hour. Remember, as unit rate, we always want to say y per x. To answer question B, it says how far will the car travel in 2 hours? Since 2 is represented on our graph, it's easy to determine without using any type of equation. You just look at your x-axis and find the number it's asking for. It's asking for 2 hours on your x, so you want to see where that crosses your y-axis, and it's 60 miles on the y, so we traveled 60 miles in 2 hours. Part C says how long would it take the car to travel 120 miles? I find 120 miles on my y-axis, and I see where that line crosses the x-axis, and we travel 120 miles in 4 hours. Now on the D part, it's wanting us to write an equation in D equals RT form to model the situation shown. This is what you guys learned last year called DIRT. And R is just represented as your unit rate, and we found our unit rate to be 30, so you plug in 30 for R and you'll have D equals 30T. That's our first example. Moving on to example number 2. The graph shows the distance D a train travels in time, T, at a constant speed, R. Write an equation in D equals RT form that models the situation shown. So basically here I'm just trying to find the unit rate. So I'm going to see where this line crosses at 2 points exactly, and I see it going through my first point of distance at 100 miles per hour and time at 1 hour. So when I use y per x, to write an equation in D equals RT form, we must know the unit rate. We know the unit rate is defined by y per x. At y is 100 and x is at 1, so we simplify that to just 100, and our equation to be written is D equals 100T.
Recall that the graph of a proportional relationship is a line that passes through the origin. An equation that models a proportional relationship can be written in the form y equals m times x. The equation y equals m times x shows y is always a constant multiple m of x. An equation in the form y equals m times x is an example of a linear equation. An equation is a linear equation if the graph of all of its solutions is a line.
Now those last 2 examples we have, if you can remember back, those graphs formed a straight line. That is known as a linear equation. Although we use the form of D equals RT, the correct form, the main form of linear equation is y equals mx. So here I have a note that talks about how D equals RT is the same as y equals mx, with the exception of the variables being different. In the equation D equals RT, R is representing the unit rate, and in the equation y equals mx, m is representing the unit rate. This example states the number of words that you can write in X minutes can be represented by the equation of Y equals 55X. The number of words your friend can type in X minutes is modeled by the graph. Which of you can type faster? We've got to be able to interpret an equation as well as write an equation from a graph. So it talks about your friend being able to write 55 y equals 55x. Well, we know that y equals mx. 55 is in place of m, and m is our unit rate. So what's that stating is that you are able to type 55 words per minute. Now looking at the graph, find a line that goes through exactly 2 points, and I see a total words of 150. It takes 3 minutes. So I will use my unit rate equation, y over x, and I will plug in 150 for y and 3 over x and simplify to 50. Now I'm going to compare these two equations. The equations of number of words your friend can type is not represented as y equals 50x. And the equation of number of words that you can type is y equals 55x. Now we know the unit rate is in place of m, so 55 is greater than 50. Therefore, you are able to type faster than your friend. Moving on to this last example. The number of miles y a car travels in x hours can be modeled by the equation y equals 65x. The graph shows the relationship between distance and time for a train. Which vehicle is traveling at a greater speed? So we have our equation for the speed of a car. Now we need to write an equation for the speed of a train. So once again, this is unit rate. Speed is represented as unit rate, so I'll use y over x. And I find 2 points where this line crosses directly through the 2 points, and it crosses where y is 75 and x is 1. So I'll plug 75 in for y and 1 in for x, and that simplifies to just 75. I plug 75 into my m for unit rate. My equation is y equals 75x. So what this is stating is that the train travels 75 miles per hour, and our car is traveling 65 miles per hour. Therefore, train travels faster. Now I'm going to show you real quick some closing check. Now I will show you the solutions.